So this question under static equilibrium, let's see how we can break it down to find what we're looking for. So the question reads, in the figure below, the tension in the horizontal chord is 30 newtons. So we have the tension pointing towards the right. Then what we're looking for is the weight of the object. Remember, these are three ropes which are connected, and what we're looking for is the weight of the object. Let's break it down so that we can see how we can find out this particular weight of this object. Okay, so this is the rough diagram that we have here. So let's see how we can break it down. So the diagram is not accurate in terms, it's not up to scale in terms of the angles. It was just roughly drawn. So here's what you need to know. Let's assume that here this is tension 1, then here we have tension 2. Here we don't need tension because we already have a force there. So what we need to do here is we need to break down tension 1 into components. So we need an x component in this direction, then we need a y component like that. So what we've formed here is a right angle triangle. So this angle here is 40. So how do we know it's 40? You can say 90 degrees minus 50, or we can use the rule of z, then we know that it's 40. So this is T1 in the x. This is T1 in the y. So according to SOHCAHTOA, the opposite, we're going to be using a sine. So this will be T1 sine theta. This one here will be T1 cos theta, like that. Now remember, since this is T2, we're looking for weight force, which is this one that we have here. So we're looking for this weight. So let's sum the forces in the x, we sum the forces in the y, we see how it reduces. So to start with, the summation of forces in the x is equals to 0, because remember this system is not moving, it's static. So the two forces that we have in the x-axis, we have 30 and T1x. So the one going to the right, we can consider it as a positive, which is 30. And the other one going to the other side, you can consider it as a negative, which is T1 in the x. Everything is equals to 0. If this crosses the cosine, we'll have 30 is equals to T1x. Now remember, T1x is T1 cos. So 30 is equals to T1 cos. The angle we have is 40. Meaning that the value of T1 will be equals to 30 divided by cos 40, like that. So we can find the value of tension 1. So tension 1, T1, if we divide these two, tension 1 will be 34.6 newtons. So we have T1. Let's see how we can calculate T2. To find T2, we're going to go in the y-axis. So summation of forces in the y is equal to 0. So we only have two forces in the y. We have this force here. So remember the direction. This is going in that direction. This tension here is going in this direction. So T2 is going downwards. T1y is going up. So the one going up we can consider it as a positive, T1y. The one going down we can consider it as a negative, which is T2. Everything is equal to 0. This will give us T1y is equals to T2. So T1y, we're using T sine. So T1 sine theta is equals to T2. Now we have T1, which is this one here, and we have theta. So we can say here where there's T1, we replace it with 34.6. Sine, the angle there is 40. So let's see what we obtain as the value of T2. If we compute this, we'll see that T2 is equals to 22.2 newtons. Now, since T2 is the one which is attached to the object, we can simply say tension 2 is equals to the weight force. Now, since tension 2 is 22, then the weight force, in this case, will be equals to 22.2 newtons. So that's what we're looking for. Thank you very much. In case you have a question, please feel free to drop it in the comments. Have a good day.